Welcome to The InEVitable, a podcast by MotorTrend. Inspired by the future, designed for the now.
Hi there, and welcome to another episode of The InEVitable. This is MotorTrend's podcast, our video podcast, also known as a vodcast, about the future of the car, the future of transportation, the future of cracked windshields. In fact, will cracked windshields even have a future?
Not if our next guest has anything to do with it. We're talking to Corning Automotive Glass Solutions VP and General Manager Mike Kunigonis.
Well done, Ed.
Came all the way to us from sort of middle of New York, halfway between New York City and Toronto. And he's going to tell us all about, it's cold. He's going to tell us all about what's going on with the glass in our car, not just the windshield and not just how Corning is trying to make them impervious to cracks, but also what's going on with all the screens in the car. And then oddly, optical fiber. So fiber.
Odd until you hear what this guy has to say about fiber optics.
Fiber optics. So Mike Kunigonis, super nice guy. Be gentle with him. First podcast ever. He is a 20-plus year veteran of Corning. He's an engineer. He was in the Army. He's a father, dad of two young girls. Super nice guy, super knowledgeable. And again, we're going to talk to him all about what Corning Glass is doing. They, by the way, they are probably if you're watching us on your tablet, on an iPhone,
laptop,
even a laptop,
TV screen.
Good chance that Corning supplied the glass for that. Also, their products are on, so they're on iPhones, they're on iPads, they're on Android phones, and then they have been making these fiber optic cables for all sorts of different manufacturers. Like they might provide the Wi-Fi in your home, or they might be part of the data transmission cable that goes between the continent you live on and another one. Who knows? We're going to talk to Mike and get all the answers about what the future of glass is in the car from a EV, software-defined vehicle, kind of everything perspective. So without further ado, Mike Kunigonis. So Mike Kunigonis, VP and General Manager of Corning Automotive Glass Solutions, thank you so much for joining us here in The InEVitable. Bing. It is your very first podcast, so we will not take it easy at all. We chatted with your colleague at CES, so I don't know. Let's start with newest stuff or future facing. That's the podcast. First, and I understand you guys announced or are working on some new optical fiber solutions for some kind of problem we might be facing in the future with vehicles. Can you explain what this is?
Yeah, so maybe we can start with what is optical fiber.
Yes, that'd be great.
So optical fiber is it's a piece of glass. It's actually two pieces of glass, and you've got an index of refraction, the two different types of glass that are where light is kind of propagating through the glass. And basically versus copper, you can go a lot further distances and you can do a lot more data transmission over that. Okay. So material was invented 50 plus years ago.
And we know this is fiber optics. It's
fiber optics, right.
Termed. Yeah.
So fiber optics. So this is how people communicate between continents, between cities, now in cities, now going to our houses. So it just keeps getting closer and closer and closer to folks, and so it's probably going to go get into the vehicle. Right now, data is transmitted inside the vehicle with copper, and because we're putting so much more sensors in the vehicles, we got more bigger displays, we got autonomy going on, you want really low latency in the vehicle, the amount of bandwidth moving around in the vehicle is a lot more. And then the ECUs are they're putting less and less of those, so they're making sure that each of those ECUs do more work.
Right.
And so as a result of that, we're getting, I think, at the end of the decade, where we're really pushing twisted pair and coax in the vehicle to the limit. And next decade, you're going to see optical fiber now replacing that.
And what's like the bandwidth jump? Like how much more data can you push through a similar sized fiber optic cable as compared to like copper wiring?
Yeah, it's like nearly infinite. Right?
Yeah.
Nearly infinite. So I don't think you have a tremendous amount of future proofing that you're going to be able to get with the optical fiber. Copper systems, they basically redesign the connectors, the types of cables, every SOP, because the bandwidth keeps going up. And so you're going to get that
start of production. Yeah,
every start of production.
SOP.
Yeah, thank
Breaking
you.
down the jargon. All
I
right.
appreciate that. And so you're going to be able to future proof because you can get a lot more bandwidth through the optical fiber. We kind of use in the from a technical jargon when you're starting to move 100 gigabits per meter. Per second per meter through the media, you kind of get to where the economics better work for optics versus copper.
So in other words, on a dumb vehicle, you're not pushing that much data. But then when you start to get modern vehicles, you will be getting into massive amounts of data. And it's just going to get more and more as cloud computing takes over the car. Then the fiber optic or optical cable solution pays off.
Yes.
Okay.
Yes.
Let's. This is great. Let's break down some of this because I like where we started with like what is optical
Can I
fiber.
ask one more real quick? Though I imagine the weight savings because like
We're gonna get
Rivian
there,
famously,
we're gonna get there.
Well, hang on.
Yeah,
About to
I'm
say,
sorry.
famously on their Gen 2, they just pulled, I forget,
1.4
1.6
miles, 1.4
plus
miles of cable.
45 pounds of copper out of the
Yeah.
vehicle.
Yeah.
And so is it a massive weight savings?
It is. It's probably about a 30 to 40% weight savings for about the same amount of cable because the cables are smaller. So they're going to be able to bend better. So you can kind of put them in different places inside the vehicles. Maybe get to a camera that's in a door that's articulating back and forth. So you're going to be able to get the weight savings. And the cables, because they're smaller, they're a lot easier to install. So if you think about the car companies and the folks that are on the assembly lines, it's going to be a lot easier to move those gigantic cabling harnesses into places in those nooks and crannies in the vehicles.
I was at the G-Wagon factory in Graz, Austria, Magna Steyr, it's a factory, and they had the wiring loom for a G-Wagon is 6 miles of copper, and it's about 100 pounds. And there was these women mostly did it, but they would front load them with this huge wiring loom, and they'd go and like splash it in the pan of the vehicle. And it was insane. And that was the last gen. I don't even know that this gen's probably more. But
yeah, they just keep getting bigger and more complex, and you put them in the car, you never want to take them out. Right.
You can't take them out. Yeah.
So let's go back to where we started. So fiber optic cable, it's actually glass. Like it is. It's
actually glass. Yes.
Okay.
So it's there's two different types of glass here. We then kind of coat it, put a coating on it, then we put it in a cable. But the actually part where the light goes through, that's very, very small there. And you're basically playing on, you're trying to kind of trap the light in this tunnel. Right. So you have what's called an index of refraction.
It's literally bouncing the light up and down all the way through, right?
Yeah. So the index of refraction of like the inner core and the outer core, or the outer part, are different. And so it kind of bounces around. So you see like a light going into a pool, and it kind of shifts as it goes from air into glass. So that's like the air and the glass the water have two different indexes of refraction. So we have the same thing going on, and we just want to bounce that light. And if you do that, you can go 60, 80, 100 kilometers without having to regenerate that signal. So you can go. You're not doing that obviously inside a car. So you have no problem with degradation inside the car.
And what's bouncing? It's literally the ones and zeros, right? Like it's
a laser light. So on one side you might have an LED, you might have a laser, kind of depending on kind of what wavelength you're working at.
Okay.
But basically, that light is just bouncing back and forth, and to get from the transmitter to the receiver that's on the other side.
Right, and so it's like encoding on one end, decoding on the other end. These
ones and zeros.
Ones and zeros, which is wild.
Yeah.
Because this is the cable, as you mentioned, that has been laid between continents for data transmission, and was recently cut suspiciously by some entities we won't name on this show. But yes, weirdly some anchors dragged and accidentally cut the major communication lines. But those are like super thick. Are they?
Yeah, they're a little smaller than that, but it's pretty amazing that they can drag those things back up to the surface, and then they can repair them and throw them back down.
Okay.
So
and then I'm trying to bring this home too. So now you know what optical fiber is. You've heard about it in the news, but in your home, I mean, it's not like super new stuff. Like I have a TV. I got this old Sony, and it's got an optical port on it, and I got the cable for it. So I'm going to pressure test you because you mentioned twisted pair, which is jargon for basically copper wire, two copper wires. Coax, which I think everybody knows, it's a wire inside a wire, right? Coaxial, and then optical. For the Super Bowl on the TV, actually you watched it in a hotel, but in your big screen at home, are you plugging in to the entertainment device of your choice with an optical cable? Or are you using?
It was interesting. I used to. Okay. I used to, and I didn't use actually glass fiber. I used plastic optical fiber.
Okay.
So there was a standard for AV systems where they could use that.
Yeah.
They've since gone back to HDMI.
HDMI.
And that's pretty
because
ubiquitous.
I used to have an optical cable, and then I got a new receiver, and I was like, yeah, do
So
HDMI.
why did we, for a period of like 10 years, say, hey, you should use this optical thing for your TV?
Well, I think for that short distance, it was cheaper to be able to do the copper, and then the other thing we have going on is a lot more wireless inside the home. So as the wireless standards keep moving up, that's what's been having the devices go back and forth with data. And then what you have is you actually have fiber going into the homes to go get max amount of bandwidth into the home.
That was like FiOS was.
FiOS that's from Verizon.
Yeah, Verizon's. Yeah.
I had that in my neighborhood, and then they're like weirdly were pulling it out. I don't know why. Too expensive.
But there's got to be a huge environmental impact from switching if the automotive industry switches from copper to fiber optics. Just because people always cry about cobalt mining. Cobalt's my understanding is it's a byproduct of copper mining. Like there aren't actually any standalone cobalt mines. Yeah. You mine copper and then you get about 10% of it or whatever is cobalt. So you'd be using a lot less copper, obviously. So
there's no metal. No
yeah,
metal,
but I'm sure Corning has looked into this or trumpeted this or.
Well, so first you said everything's lighter, so that's just going to be great for everyone because we're moving around a lot less mass, so that's perfect. Second, the glass itself is very inexpensive to make. It's a lot less, much more. It's much cheaper than making copper.
Right.
So when we make our glass, the spaghetti, that's orders of magnitude more expensive per unit length than optical fiber. It's a very inexpensive material. Right. It has a tremendous amount of bandwidth capability.
And so what's been the holdup? I'll give you my my best friend who sadly passed away, but he had his PhD in he was an electrical engineer and he had a PhD in nanophotonics. And I remember he was working on a project where they were doing this for airplanes. I have no idea if it was with Corning or not. And I said, hey, you should do this for cars. And he's like, nah, you don't need that. It's so short. And I was like, no, it would be great for cars because all the reasons we've talked about, get the weight out and faster and more data. But why the weight? Like, why hasn't this? Is it just the amount of data being sent hasn't reached like a tipping point, or it's an
well,
old
actually,
technology?
we used nanophotonics, a version of that, in the cables, in the fiber. So if you take a fiber and you bend it, light starts to leak out, right? So then you actually have an attenuation event. And so we put nano perforations in that core to go redirect the light. So we're actually doing a bit of that so that now you can go around really small bends. So you can take an optical fiber, kind of wrap it around a pencil mandrel, right? And you won't have any light leak out of it.
And nanophotonics, I mean, we're completely in the weeds, but that's like photon manipulation. That's like moving like literally
really,
a light
really
particle.
Small light particle.
But like doing what you want with it.
Yeah, and we're manipulating it at the material level to kind of direct the light where we want it to go. But you're right, there's also things going on at the transmitter and the receiver to be able to help that. And that helps with not only bandwidth, but I think they're doing some encryption work there.
Right. But was it like the you're saying by the end of the decade this will happen? Why didn't it happen last decade? Like what's
big copper trying to keep the man down.
Besides big copper.
Right.
Big copper. Big copper.
Big copper.
Playing the copper guys. No, but it's all bandwidth, right? And at the end of the day with the car companies, it's economics. Right, so they like the weight savings. They like that you can put in tighter bends. They want to help their employees on the line, but at the end of the day, it's got to be cheaper, right? Given the needs that they have. And I think they're getting to that point as we get to the end of the decade where the economics prove out, given where the bandwidth requirements are at. And you kind of know that because you see the car companies. They're in the standards organizations now, building for 25 megabit and 50 and 100. Okay, let's go figure out how we're going to go do this so they get standardization across the industry. And they're very active now.
Do you have an inkling of like how much bandwidth? Like, in other words, like, okay, if you're by the end of the decade, are you looking at the 100 megabit, or is that's not future proofed? Like, you got to be at the gigabit level. How much data will cars be pushing?
That's a great question. I think it comes down to like how are we going to solve autonomy, right?
Right.
And autonomous systems, they're going to use a lot of sensors and a lot of different types of sensors, cameras, lidar.
LiDAR has got to be
RF,
be bandwidth intensive, right?
Yeah,
I mean,
and then the latency. You got to be able to. The car's got to make a decision
split second.
very, very quickly and integrate that across multiple sensors all at the same time. So you want very low latency. You're going to have very high bandwidth, and if they have a lot of redundancy out there, that just is pushing up the bandwidth.
Right.
So I think based on how we solve that problem as an industry, that'll kind of create that tipping point of when you'll see a lot more
And
optics in
dictate
there.
like the size of the pipe,
Yeah.
so to speak. Just
Yeah.
like how, I mean, because like my understanding is there's almost no limit on what could be transmitted with fiber optics. I mean,
Yeah.
it's a size of data that
You change out
it's
the
a
ends.
library.
Yeah, you change out the ends, the transmitter and the receiver,
Yeah.
but the cable itself is pretty future proofed.
If
Wow.
you're listening and you're like, what are these guys talking about? Our man Frank Marcus
I'm saying that too,
did
by
a
the way.
great story on this from CES, and really in this intro talks about how right now, like the most advanced software-defined vehicles out there are pushing around about 1 gigabyte of data, but he's speculating in to your point, by the start of the next decade, it likely will see a tenfold increase, roughly on 10 gigabytes of data
Jeez.
being pushed around inside the vehicle.
Yeah,
And-
because 2028 now is only 3 years away.
Yes, exactly. Olympics, baby. So, and to Johnny's point, and this is where I kind of will come back to, because you asked, how do you know? Like, how do you plan for this?
Yeah.
Like when you go to CES and you see, like NVIDIA is like the hottest thing. They're talking about these ThinkWell GPUs, and we're paying attention to these car manufacturers that are announcing that, we're putting. I was talking to some Chinese manufacturers, and they're like, we don't just have 2 NVIDIA Drive Orin chips, we have 4 because we're future-proofing. I'm just like, this sounds crazy expensive.
Yeah.
But then you start talking about like, well, how much data do you actually need in the car, and then how much data are you going to move around? And we're looking at what I think Frank mentioned, that the upper limit of copper is, was it 200 gigabytes per second? No, that's the lower limit of optical is 200 gigabytes per second, which sounds like a lot. That's like that's
But we can go lower, but we can go higher too.
right. So what do you when in your position as you look towards the future? What signals, like, are you looking at these chip manufacturers going, okay, we got to start like pushing or start ramping, or like how does it work on your side?
Yeah, so it all starts with the car guys. Right?
Okay.
We go to the car companies, and we do a lot of future-proofing sessions with them. We'll get in front of them and kind of understand, what are you doing from a design standpoint? What are you doing from a connectivity standpoint? What kind of bandwidth are you going to need? So we can figure out what is the next problem, challenge that OEM is going to have. And so we'll ask them point blank, what type of bandwidth do you think you're going to be moving through the car? And then when they tell us, and they say, we ask you, well, which tier 1 do you want us to work with to help solve that problem? Because we're pretty far back in the supply chain as a material company. We'll find out who that is, and then we'll kind of work with them on what the protocols are going to be and kind of target of the dates that we're going to need to be ready. And then we kind of put our innovation machine in gear to go help the car companies help the industry.
Because this is not like, we're not talking about. I know we talked a little bit about like home personal electronics. Or G-Wagon wiring harnesses. You're not going in and swapping this out of your vehicle. This is
No,
baked
not this one, yeah.
baked
Ground up,
in,
yeah.
because you said SOP start production. You need to be in a manufacturer's plan from like the pencil sketch of the vehicle and whatever the screens you're going to put in. You're like, okay, if you're going to want to do that, then you're going to need to upgrade from copper to optical, and then become part of the manufacturing process of the vehicle.
Yeah, absolutely. And I think our first biggest problem was fiber optic seams with lasers, and that seems kind of hard to do. I don't think I have a very harsh environment in the car. How's it going to work?
Right.
And you mentioned Fios and Verizon. We've worked with customers like that to go solve a lot of problems to be able to go make connectivity work with optical fiber. So first thing we got to do is prove that actually the tech works. Okay. So they say, okay, this actually works. And then we go, what's going to be that intersection of when the bandwidth is going to require me to start to have that conversation of like, should copper or should fiber be doing this from an economic standpoint? And then once they get there, then they get all those ancillary benefits around weight, installation, things of that nature.
Okay.
But that starts at the top of the company, and then in the technical engineering parts of the company, we'll be doing conversations with both of those so that we kind of get the timing right.
And I just found it interesting you were saying with it's more flexible and you can put it in more places than copper.
Yeah.
And I was just thinking like, you said that like a Lamborghini door, you can maybe like articulate it more now, or like Jeep doors that come off instead of having that crazy 10-pin connector. You could probably have a much smaller, easier kind of connector, because that's annoying once you've unscrewed a Jeep or a Bronco door. Like the hardest part is then getting the the pins in, pins out. Yeah.
Well, let's talk about that. What are there are certain requirements, obviously, to become part of like literally the foundation of the vehicle, and a lot of it is the durability aspect.
Yes.
So like, I can imagine that what the advantage of optical fiber is that it doesn't like short out theoretically, right?
No.
What about like vibration, or are there issues with like are there wear and tear issues with what's essentially? I mean, I'm still weirded out. It's glass fiber. Like, doesn't it break? Like, can I? At some point, you mentioned you can wrap around a pencil, but if I just boink, does it snap? Does it?
No, we actually used to do this test with the Verizon guys where we would take a staple gun and we would staple the cable, and the glass would have no problem. So the cable, not an issue. Now you think about vibration and other goop getting into the vehicle, like windshield wiper fluid,
or water,
or water,
yeah,
like freeze off.
It's raining outside,
right?
Yeah.
So your FiOS system, that sits in a manhole, and it gets frozen, and then it unthaws, and then there's all type of stuff that's inside there.
Okay.
No problem. So we not only do we make the fiber, we make the cable, and then we make the connectors that are on there. And so it's kind of a system approach. We'll put all those things together based on the use case to go solve the solution for the customer.
Now, can you splice optical cable? Like if I go in and I snipped the wrong wire and then I've got to reconnect it. Like it's repairable.
Yeah, if you can you talked about earlier repairing it out in the ocean for the submarine cables. So in the car is actually a little easier. Do that.
Well, it depends where it's located.
Yeah, you got to get to. You got to be able
a
to
few
get
locations.
But no, you can actually splice two fibers together. You can do that where you melt the glass back together, or you put two connectors on the edges, and then you made them together that way. Okay. You have all the bandwidth loss inside the vehicle is really low for the fiber, so you can have a lot of connections, and you'll still have plenty of bandwidth, light. That's able to go from to the transmitter to the receiver.
Okay.
And I imagine that it actually is probably a lower power requirement to use optic fibers than to use copper.
Yeah, I haven't actually done the math on the power to run them. I mean, you have to do an optical to electrical conversion in the ECU, but you go optical, it's basically passive.
Okay. So we'll wind this up on optical, and so I want to talk about other Corning products. But the interesting thing for me is that yes, we seem to be. The cars are moving towards more, again, software-defined vehicles, more software flowing through it, higher processors. But at the same time, as Jonny mentioned, like with Rivian, their big announcement from the first gen to the second gen of the R series vehicles, the R1S and R1T, is that they simplified the number of ECUs. They went down to 7 or something?
From 17 to 7.
17 to 7, and pulled out miles, 1.4.
I think it was actually 1.6, but 1.6 miles of wire.
Miles of copper wiring. All on this path towards what I still think is the holy grail for electric vehicles and most modern vehicles is weight reduction. Like getting the weight out of the vehicle is going to be the hardest thing because you got these giant batteries. So this is all adding to it. So it's fascinating stuff. Probably not something we're going to... Is a manufacturer ever going to... First of all, is any manufacturer out there running optical fiber yet, or your optical fiber yet?
There was a standard about a decade ago in Europe called MOST, M-O-S-T, and they were putting some plastic optical fiber in the vehicles.
Okay.
So there's some experience out there, but the industry's going to want to move to glass.
Okay. And then will you guys
But
take...
no one's doing
now?
doing it today, but we're talking to a bunch of different OEMs and the tiers, and I would expect to see this out there, in the next couple of years.
This sounds like, if I can make a wild guess, and I know you can't confirm, 2029 S-Class, because Mercedes loves to have hyper technology on their new S classes.
Well, to that point, do you expect? Will they tell the consumers? Will they be like, "Hey, man, your car's got optical fiber"? Is that something that will be?
That's a great selling point of the vehicle. I like that. We'd love to partner with a car company to be able to do that.
Well, we can help because I think it's pretty cool. So
No, but I remember one time like Audi's like, that Audi was the first manufacturer to use LED daytime running lights,
yes.
and I said, the Reliant Scimitar was the first manufacturer or first car with a split folding rear seat. And they kind of stared at me like,
Well, I went on the press trip when Audi showed off the future of LED lighting. I was like, this is, and they gave us one. We went home with a little battery and an LED connected. I was like, this is wild. And then 2 years later, the car's on the road. I was like, this is quite cool.
Consumers are smart and car companies are smart, and they're always looking for an angle.
Yeah.
Is there a market that you can tell where the consumers would be hungrier for this tech? And I'm leading like, when we talk to Chinese manufacturers, they'll say like, yeah, people bring their cars back. They're like, the new chip's out. Give me the new chip. Whereas like Americans are like, more horsepower. I want more power. But is there any like, do consumers have any knowledge of this? Are they hungry for it?
When we talked about autonomy, I think that's going to be where the tipping point is for the material, for the connectivity material to switch.
Right, and so
and then a lot of EVs are going to be more autonomous, so it's probably going to be in that area.
Right,
and then there's other areas like think about like Class 8 trucks, like really long trucks. So they've got cables to have cameras that are going to go all the way to the back of the trailer.
Right.
And they're trying to reduce the number of ECUs as well, so you can kind of get home run all those things back to the cab. Yeah. I think that'll be an area as well.
Okay.
Right.
So Corning, looking ahead to the future of software-defined vehicles, autonomous with fiber optic cables in the cars. But as we talked about, there are some other more mainstream current applications from some big manufacturers that you can talk about around your glass products, specifically Gorilla Glass, which is in the iPhone, which is also in a few cars' windshields or windshields. Jeep, Porsche, and there was one other one. What was the other one we could talk about?
Jeep,
Porsche.
Did some work with Ford.
Oh, yeah, the Ford GT.
Yep.
Yes. Okay, so you supply a number of OEMs you can't talk about, but what's your favorite of the automotive applications that we can talk about? And then, because I want to talk about where we are with Gorilla Glass and then this other product you have coming, the Fusion 5,
Fusion
right?
5,
Yeah.
Well, Corning is a company loves to solve problems. That's why I joined Corning more than 25 years ago. And windshields breaking, that's certainly a problem.
Yep.
Right? For consumers, we all hate that. And kind of depending on the type of car that you have, some are more prone to it, kind of depending on kind of that angle of the windshield.
Like a Wrangler.
Like a Wrangler Jeep, yeah. So when you get that windshield sticking up nice and proud like that, it's just a big rock catcher. And so a lot of things are hitting it. So how can we solve that problem? So we've worked with, when we worked with Ford, we first worked with them in the 60s. And actually, the Gorilla Glass got its origin from that collaboration with Ford on the GT back in the 60s. We invented not only some glasses and some manufacturing processes, but the chemical strengthening process where you actually strengthen the glass.
On the original Ford GT?
The original Ford GT. Yep. We actually were air shipping windshields out to Le Mans to help out the GT and some of the origin story of that.
No kidding.
Yeah,
that's great.
And obviously we got it back on the more recent GT, so we're really proud of that. But basically, how do we go solve? How do we use this material, Gorilla Glass, to be able to go make the windshields lighter, have better optics, and ultimately more reliable and durable? And so that's what we've been doing for many manufacturers, a couple that you mentioned. And basically what we do is we originally thought, hey, let's put the Gorilla Glass on the front of the car because it's super strong. But we actually found out it can improve the reliability if you put it on the back. So the Gorilla Glass is actually, a windshield's got two pieces of glass, a laminate. It's on the inner laminate. And the reason for that is when you have a strike event, the windshield is basically starting to flex. And so you want the strongest piece of glass on the inside. So that's where we place that glass. And then you put a really thin piece of glass, so that makes the outer really thick. And that's important because most of the rock strikes are what come from sharp impacts, little stones that got little angles on them. And so you want more material to have to puncture through before you actually break it.
Okay. So how many layers are in your standard windshield? It's two, but is there
Two pieces of glass.
Two pieces of glass,
and
but there's
some PVBs in the middle.
So PPE meaning
Plastic.
plastic, polypropylene.
Yes.
Yeah. So is there like one on the outside, one on the outside of the outer glass, and then is there anything between the regular glass and Gorilla Glass, and then something then on the inside? Or
Yeah, you'll have a typical windshield will.
Yeah, what's the construction
Yeah,
of a typical
typical
windshield?
windshield is like a piece of soda lime, two pieces of soda lime, both the same thickness.
glass. Yeah.
Of glass, right? So like 2 millimeters thick typically.
Okay.
2-1. And then you've got a piece of plastic in the middle, and then another similar thickness piece of soda lime glass on the outer. And that's safety glass that's been out since the 50s and 60s, and it just ensures that stuff doesn't get into the cabin and we don't get out of the cabin. Right?
Well, I mean, if you go back and read Nader's book about what cars were like before safety glass, and it's jagged neck wound punctures were real common.
Yes. So now what we do is we take those two pieces of glass, which were in a symmetric construction, and we make it asymmetric. So therefore, the outer is much thicker and the inner is much thinner. So we put our technical glass on the inner ply, and as a result of this, you can improve the reliability of the window. You can also spend that reliability, like Ford did, by making the whole stack thinner, and therefore it's lighter. So they did that to make the windshields about 30% lighter.
And then
so if you're
Porsche-
racing around that, and Porsche does
With
the
the
same
GT,
thing.
it was one of the first time I saw it was the GT3 RS, and it was they just wanted it thinner for more sound in, and then just lighter.
That exhaust coming in. It
was only the rear glass. Like, my understanding was the front was regular Porsche glass, and the rear was Gorilla Glass. That's a place you could lighten. It has no effect.
Right.
The downside is it's louder, but everybody wants it louder. So
Yeah, they wanted it lighter. They want to make sure they kind of what's that sweet spot between safety. All right, so I've got the right safety glass on the vehicle, but I make it as thin as possible so that now I can spend that somewhere else, and typically spend it with performance.
Right. Okay. So wow. So Gorilla Glass, or the predecessor to the trade name, right? Because it wasn't called Gorilla Glass back then.
Yeah, it was like Chemcore Glass. Yeah, we're not a marketing company. Right?
But 1960s, Chemcore was really
Chemcore was
sexy.
super cool.
Very
Yeah.
sexy. Yeah, Chemcore.
On the original Ford GT windshield, and then on the latest generation, and then certain models of Porsche 911s, or are you not across the board? Does any manufacturer go like, we're across the board Gorilla Glass?
No one's across the board, but we have obviously a lot of other customers that we're dealing with that we sell to. We don't kiss and tell,
Right.
But there's others that are using the material.
Okay, and then for all iPhone users here, is that construction? Is it the same, similar to an iPhone? Is iPhone or is it just all Gorilla Glass? Like how does
Yeah, so it's definitely a different construction.
Okay.
So we're not putting a laminate on the front of the phones.
Yeah,
You've got a piece
they're
of
not struck by rocks at 91.
no,
an hour.
we're dropping them on the asphalt and
different
concrete.
use case.
Right,
Yeah.
yeah, exactly. Yeah. So we solve for a different use case there. The material is slightly different, but it is still a chemically strengthened material.
Can you tell the story of how you, Corning, got in touch with Apple for the glass for the iPhone? Because I've heard it a little bit, but I hear it's a pretty cool story.
Yeah, it's a good story. So they actually got in touch with us. Steve Jobs had this great idea. He's going to make the whole front of the phone a display. So he needed some transparent media to cover it. So he first used plastic.
It was going to be plastic,
It's
right?
been plastic. So he's got it, and he wears jeans all the time. It's kind of in and out of his pocket, probably touching his Porsche keys, because I think he drove Porsches.
Right.
And scratching all up. And he's like, this is going to be a huge problem. And so they reached out to us, and actually just called Corning, got to the main switch, and the person that answered didn't know who he was, and they're like trying to get to our CEO.
So wait, Steve Jobs called Corning?
Yeah, so hey, we've got Steve Jobs, and they're like, oh, you can't talk to our CEO. Like, you need an appointment. Eventually, we got the two of them together.
That's great.
And Steve's like, hey, he described his problem, and our chairman, he's still Wendell Weeks is our chairman and CEO. He was back then. He still is today. He says, I think we've got something on the shelf that probably can help you. And that's why we took this process then they make the glass, the chemical strengthening process to be able to strengthen the glass, and then the regular glass, and then we put it all together. Got that back to Steve. He's like, okay, I want that, and I need it in like 4 months.
Yeah,
And
that's
so-
that's the part. I heard it was like overnight, but I guess
Basically,
in the industry, 4
and
months.
we're
is
making
overnight.
glass over 4 months is pretty fast.
Yeah,
Right.
Yeah,
So-
it'll be a small order, after this thing takes off. Like
Yes.
and that seems to be a big success for you guys.
It has been. Yeah. So, and it's again created a big
Yeah.
consumer electronic business for us.
Sure.
And so we went on to other devices, and I think what they've done is really created this unique connection between us consumers and our devices, and now that's what's found its way into the vehicle, into the car. And so we're just trying to help replicate that. Having done that, more than a decade ago, we're trying to help car companies do the same thing in the vehicle.
Did you have any inkling that the iPhone, and again, this is a little off topic, but that would be the success that it was?
Yeah, and hindsight, I was like, oh, yeah, I would have saw that. I wanted that. But I think, remember, Nokia was huge back then.
Right.
Motorola,
Blackberries.
the StarTech,
Oh,
BlackBerry.
BlackBerry.
Let's get rid of the keyboard. What a great idea.
I'll never forget that. I remember a friend of mine, Scott, had brought an iPhone to a party, iPhone 1, and I was like, why would you want that? And then he pulled up a YouTube video, and I remember I was just like, it's all over. I'm like, this is it.
This is
get,
it.
Get an iPhone now.
Yeah. So we believed in them, and they obviously believed in us, which is great. And it's been a long history together.
So Gorilla Glass is the current hotness, and you guys have this new product out there called Fusion 5, which I think is interesting because strictly from a design, one of the solutions you're trying to provide from a vehicle design standpoint, which is like all these cars are getting like really slippery and with like the crazy raked
Because aero counts.
windshield.
Finally.
Like the you ever look at everyone's like remarking the Prius these days. So, yeah, it's pretty hot. It actually looks like somebody sat on the front of it. The rake of the windshield is so
It's a Lamborghini rake.
yeah, it's crazy. And then what you don't understand, this is something we figured out when we were doing World's Greatest Drag Race many years ago. When you're driving cars really fast in dirty runways and you get rock chips and you try to protect against it, and we were trying to protect these like Lamborghinis, we were stupid. We were putting plastic like the stuff you'd put on the front of the car on the windshield. Because it was the only thing available.
And it worked.
But the
Couldn't see.
the visibility went down like crazy, and it's amplified by the rake of the windshield because now you're looking through a much steeper angle, and it's way easier.
But we were only hitting like 150, 160.
Yeah,
at
I
the end.
remember
There's no problem really.
At the end of the drag race, people are like, "Okay, how do I know when to lift?" Like when you see the blue flash of the porta potty, lift,
Right.
because otherwise you can't tell what it is. But let me. This is a long intro to Fusion 5. So you talked about soda lime, which is the standard glass that's in everybody's
It's window
house,
glass.
car window glass, right? And then Gorilla Glass is an upgraded version that adds aluminum oxide.
Yes,
as
aluminum silica glass.
aluminum silica glass, okay? And we'll come back to that actually because I think there's a Pyrex angle. Oh, which is Fusion 5. Fusion 5 is borosilicate glass, which I know because I'm a cooking nerd, which is fundamentally sort of like Pyrex,
Yes.
right?
Yep.
So Fusion 5 is a cool name. So you said you're not a branding company? It's a pretty cool name. Well, what problems is Fusion 5 trying to solve that maybe Gorilla Glass couldn't, let's say?
Yeah. So we're a glass company.
Yep.
So we want to sell glass. And I told you about how the Gorilla Glass was on the inside, and they still were using the regular soda lime on the outside. So we
Okay.
say we want to go after that.
Okay.
So how do we go after that? Because we don't make soda lime. We only make technical glasses in the company. So we continue to go engage the car companies, kind of understand what the problems are, and so they wanted weight savings. And so a borosilicate glass, by definition, is a less denser glass. So it's about 12% lighter for the same volume as soda lime. So that kind of got us into the right kind of glass family.
Okay.
So it was the first thing we had to be able to solve. Second, borosilicates are much less prone to scratch.
Yep.
And that's important as you kind of drive your cars around. They kind of get pitted, and now we're kind of putting cameras and things like that behind our windshields. Yeah. And so the camera's got to work obviously on day one, but it's got to also work, year 2, year 3, 100,000 miles. So how do we ensure the material ages well? Right, so borosilicate is going to age better, and so we're on the outside, so that's the area that's going to be engaged with the outside environment. So we knew we would have to do that. And because it scratches less, it's gonna go damage in a different way. Right. So normal glass, when a rock hits it, it's going to fracture and then a crack runs. And actually, when your windshield breaks, typically it got hit, but it didn't break right away.
Yep.
You need some type of other stress event, like a flexure event, or you go into a car wash and cold water hits it, and then or you wake up in the morning and there's a crack across your windshield.
It's gross.
Super frustrating.
Yeah.
Right. So we wanted a material that crack propagation is very different. And a borosilicate kind of fails in a very different way.
How does it fail?
Glass. Instead of kind of running, it kind of goes in a circle.
Okay.
And
more like spiderwebby looking.
Well, it kind of encapsulates the flaw
Okay.
Where the damage has been introduced. That's where it typically will go, and kind of go through the glass, but it won't run in the same way that soda line glass was. So it just fails a little differently.
Okay.
And then we make glass. There's kind of two different ways to make glass. One is a process called float. Pilkington invented it many years ago. Really good, inexpensive way to be able to make glass. We use a different process. We use a process called fusion, which comes into the name of the glass.
Okay.
And this is basically, instead of horizontally making glass like float, we make it vertical, right? And so as a result of that, we have really good optics in the glass. So really low distortion. The surface is really good. This is why glass. We sell glass for your laptop screen there, for the TV right there. So it's a really good precise surface, and so that helps with the optics. And you're looking through these windows now with different camera systems, and then that becomes harder as the rake angles get smaller. Or steeper and steeper because you actually have to look through more glass.
Right.
And so we help solve an optics problem there. So we wanted a lighter material and had better optics.
And there's isn't there a thermal advantage too? Isn't it not less? Is it less prone to thermal shock? Is that what I read?
For the damage
circuit?
introductions that happen, right?
Okay.
Right. And so it actually has a lot. So some windshields will fail on the edges. And they'll also fail on the surface, and so that actually helps with edge stress.
I was again. Frank Marcus wrote another story about this one too. From I think it was CES last year, and the example he used was. And by the way, it's not. We don't live in a cold climate, but if your windshield is covered in ice in the morning, you probably shouldn't throw a boiling pan of hot water on it.
Probably not.
Probably not, right? Because that will it could shatter the thermal shock, right, from the hot water hitting the cold windshield.
If it had a big flaw in it, you probably would kind of activate that flaw.
Okay.
It won't shatter though.
It won't shatter. So you guys are trying to then replace the soda lime glass in the front, and so it'll be a sandwich basically of this Fusion 5 glass with the Gorilla Glass behind it. Okay.
That's the kind of our ultimate construction. You can be able to make it super light, more reliable.
And is Fusion 5 has it hit the market yet? Is there an OEM that's supplying it yet?
Yep, it's in mass production today.
Oh, okay.
We launched it about a year and a half ago. We kind of went to market at CES last year. And,
But Corning's been around for a long time, and borosilicate glass has been around a long time. Is it 100 years old? Borosilicate's not 100 years old, is it?
Borosilicates are more than 100 years old.
Wow.
So Pyrex, we invented that material, I think it's 105 or 6 years ago. So it's over 100 years old.
So the patents run out on that, right? So, I mean, because there are other people who make borosilicate glass of all different kinds.
Yeah.
So what's the unique IP here is the production method, or is it a specific formula that you're using?
Yeah, so the borosilicate would be a family, and then you'd have a unique composition. So that's our Fusion 5 glass.
Okay.
You would patent the material. You would patent the way to make it. You'd patent maybe some downstream processes as well. You kind of put all those things together.
Okay.
And then companies are always renewing. We're always renewing our IP, putting new IP on them, and then you kind of get an extension of the IP, and you kind of go beyond that first useful patent life.
Okay. Again, so for the car enthusiasts and the tech enthusiasts who also happen to be cooking nerds, so Corning invented Pyrex, over, as you said, over 100 years ago.
100 years
right?
ago. Yeah.
And
For cookware.
For cookware, and the whole family was Pyrex. There was this really cool. Remember in the '80s they were selling on infomercials. It was the
Visions.
cookware. It was
That was a Boris
Oh
Silver as well.
yeah,
It was the glass.
yeah.
You could like watch your spaghetti boil on the
Yeah,
pot.
yeah,
This is
yeah.
the coolest thing.
I
And
do remember that.
yes, this is hilarious. It's like it was like kind of a smoked gray kind of color.
When I would watch Price is
With a
Right
lot
with
of
my
colors.
grandmother, there was
Yes.
a lot of commercials for that. Yeah.
But Corning doesn't make. You guys sold that business line. It's now Corningware something. Somebody else.
Yep, we sold it in, I think it was 98, right before I joined Corning.
And then, I'm a cooking nerd. There's a big scandal about what the new Pyrex is versus what the old Pyrex is, right? Because the Pyrex when Corning was making it was borosilicate, borosilicate, super scratch resistant. It's both the white like casserole pots, but also like the clear glass containers, right?
Yeah.
But the stuff you can buy at Target, I think that the distinction is capital P Pyrex good, lowercase p Pyrex is the new stuff, which is not as the thing that people are finding out, not as thermally resistant. Like they can shatter, I guess, if you put a hot one into the cold water in the sink, but also that they chip in a different way. Does any of this make sense to you?
Yeah, a lot of it does. So you're right. Corning was, and I think most of the listeners probably that's how they think about Corning. They probably think about stuff that was
That's
in
what
the,
I
the
thought
kitchen cabinets
until
with their mom
Corel.
or grandmother,
Yeah,
right?
yeah.
And so there's actually a lot of different glass compositions, a lot of different manufacturing processes to make the Corelware,
Yeah.
the Visions. But you're right. For most of the clear glass, that was borosilicate glass.
Okay.
And so when you dropped your measuring cup or anything like that, it wouldn't break. Or if you went from the hot oven and then or the cold freezer and you kind of put it in the hot oven or vice versa, the glass wouldn't break.
Right.
It was actually when we discovered that for some of the Corningware, it was actually an experiment. We have these in Corning. We have these Friday afternoon experiments that all the scientists can do. They get kind of Friday afternoons, do whatever you want to do, right? And so this one scientist, he like kind of was trying to go target a glass composition to do something else. It wasn't obviously for Corningware,
Right.
And he kind of took it out of the oven and he dropped it and didn't break. And he's like, well, that's interesting. and then that ended up going into the consumer space
Yeah. Okay.
for kitchenware.
So
And there was a military application, right? Wasn't this like nose cones of missiles or something?
Yeah, that's we don't always talk about that, but yep, that's a glass ceramic. And,
Okay.
That's a material that you want it to fail and it kind of turn into dust and then.
Okay.
I'm
business
not
and does
I'm not a cooking nerd, but I'm kind of a watch nerd. And when I think of like scratch resistant see through, it's sapphire, crystal.
Yeah.
Why would and my understanding is this is closer to diamond than it is to glass, like a sapphire. What is sapphire, and why don't you just use that since it seems like totally scratch resistant?
Yeah, well, sapphire is it's a ceramic, or excuse me, it's a crystalline structure. So when you have a really thick piece of it, it's pretty strong. But if you cleave it, it's real easy to break it, just like a diamond. If you cleave a diamond, right?
Okay.
And so if you want to use that in consumer electronics, folks have looked at using sapphire. They want really, really thin pieces of sapphire. And so as a crystalline structure, it actually will fail at a higher rate than the Gorilla Glass does. And so as a result of that, we've always used the Gorilla Glass.
Okay, I just didn't know because diamond is like whatever 2,000 on the hardness scale, and below that is sapphire because it's carbon. Blah blah.
Yep,
blah.
diamond will scratch glass. So
Yeah,
But it's also
Yeah.
got to be more expensive to create. I mean, especially if you're talking about something the size of a windshield. I mean, little glass watch faces, I'm sure.
yeah. What we actually do is we actually take glasses and we put different optical coatings on them that can be nearly as damage resistant and hard as diamond and sapphire.
Yeah,
you'll see that on some of the new tech devices that are on many of your wrists.
Yeah, because there's a name for it, but yeah, I saw some watch where it was like it's glass, but it's just as good and it's stronger or something, right? Or just as scratch resistant. But
Okay.
interesting.
Anything
Very
else you're working on you want to tell us about?
Well, the big one was the optical fiber. That's the new one that I think is going to be really big.
Yeah.
Inside the vehicle, where our business has been growing is because there's just more displays in the vehicles, and those displays are much larger. And there are a lot of safety tests that are inside the vehicle. You have to pass something called a HIT test, a head form impact test. And so you drop your phone, that's a pretty small event for the glass versus passing this safety test inside the vehicle where you're gonna.
In other words, a knee or a skull hits the glass.
So they take this head form and smash it into the glass, and the glass can't break for it to be used in the vehicle. So we kind of solved that. We have a version of Gorilla Glass we called Auto Grade Gorilla Glass to help solve that problem. But I think now the big problem is there's just a lot more glass around in the canopy of the vehicle. So so you get a lot of light coming in, especially when the sun's behind you. And so how do you go combine surface treatments on the glass so you can manage all this ambient light? So that's an area where we've been spending a lot of time with car companies. And then after that, fingerprints.
I was going to say, I was going to make a joke. Have you solved fingerprints? But
that's $1 billion business.
That's
right
$1 billion.
We're working hard on that one.
Interesting.
We're working hard on that
No,
one.
this is
It's, I mean, just because fingerprints are hysterical because a lot of times you don't really see them until, and I spend a lot of time photographing the inside of cars, and everyone's like, "Oh, you could have cleaned it." And it's like, couldn't see it till I took the picture.
Yeah.
Well, the fascinating thing for me is because I've been in this business long enough to have witnessed the transition from analog controls to now all these screens. And I remember the Germans were so resistant to. That's why BMW started with iDrive and there's a command dial, because they were like, our cars are on the lawn at Pebble Beach, and we expect them to be there for the next 200 years. And you know how gross it's going to be when the screen that you have is covered in 200 years of fingerprint and grease, and then whatever grooves you're wearing into these screens. So do you? I mean, I was fascinated when you were talking about the glass, that you're looking at the long-term reliability and the failure. Do you look at that in the same way for the inside of the vehicle? Like, are you guys trying to do testing for what it looks like after a Tesla Model 3 from 2017 has been swiped for 50 years or 75 years? What that might look like?
Yeah, there's actually a bunch of tests for that swiping motion that we do have to do before we go to mass production. And the material and the surface treatments we put on them are pretty durable. They're gonna last beyond the life of the vehicle. So I don't think that's gonna be a big problem. But you did bring up something that I think is interesting. So. There's a lot more displays in vehicles. That was kind of the thing, a decade plus ago, and they kind of got bigger and bigger and bigger. And now, like, every car's got a screen in it.
Well, and then there's like the electric Escalade, which is just glass overload.
Yeah.
Like, there's more glass. I'm sure Corning loves that vehicle. But I mean, I think there's 7 screens. There's 5 screens for the front passengers, and then each. Maybe 9? It's just
everyone should get their own screen. But now we're seeing screens that's kind of getting boring, right? That I got all these screens. So like, how do I get back that connectivity and that driving experience? Right. So I think everything's kind of going full circle. Like kind of the more economical cars, they'll get the big screens and not a lot of touch interfaces inside the vehicles, like switches and knobs and things like that. And I think now more of those expensive vehicles, they're going back to that. Yeah. I still have to have the tech, but how to go back to that? And so we have conversations with them and go, what's the material on that switch going to be? And I think we're going to see a lot more glass inside the vehicle because when we talk a lot to designers as well, and go back to consumer. You have this glass thing in your hand. Right, this phone, and it's got glass on the front, it's got glass on the back, and there's a connection you have with that device. People just feel good about glass. It's like a great material set, versus other materials that are out there. And so designers want to replicate that experience that you get with your phone inside the vehicle. Glass is like cool to the touch. It's an inert material. It can be cleaned. It's not going to go. It ages really well. Yeah. And so, how do I get that into the vehicle? And so, we're working with designers on how do they make more complex, more inviting interiors in the vehicles. Okay. And I think there's a lot of great opportunity there.
So more glass touch points, less maybe in high end vehicles, less screen square footage.
I think they'll do both.
Okay.
Yeah.
What he's saying is, Elon's famously said, the best part is no part. So that's why he's made all his screens, all the screen to be dominant and getting rid of switches and knobs. But as we saw with Scout's like coming back and putting knobs and key switches. That's going to be the future flex. That's going to be what the luxury manufacturers like. We didn't do this as you said, all the economy cars are just going to be screen only because
Right.
that's how they take all the
Yes,
cost
it's
out.
Thorsten
Exactly.
Veblen's
Super
theory
cheap.
of the leisure class.
Yes.
Like, oh, you have screens? Well, we have screens and buttons now.
Yes,
We're rich. Yeah.
exactly. We spent the money on the tooling, and then to your point, and we're going to put this beautiful glass like knob on top of it that's going to probably like light up or do something cool or change.
Yeah.
But that's great. I love that future. Talk to me about head-up displays, and then do you actually believe that augmented reality, virtual reality, like are we going to in the self-driving or increasingly autonomous age, we're all going to be putting our heads back and watching stuff being
I wanna drive.
broadcast on our windshield though? Like, will we get to the point where the biggest screen in your car is actually the windshield and stuff's projected on it? Because I don't know. I have mixed
That's a
feelings.
great question. It's a great question. So today, the displays are winning that race, right? For connectivity. How do I like connect the car to the driver and the passenger? Certainly, the displays are winning that. But head-up displays, HUDs, could be a way. Maybe I'm going to go integrate a transparent display into the windshield itself. Maybe I'm going to do something holographic and it kind of pops up.
Yeah.
I think the whole front of the vehicle is a canvas for these designers to think about, well, how do I go, convey connectivity to customers? So we actually have plays in all of those areas. We monitor all of them because we want to be able to pivot with the OEMs where they want to go. So we make mirrors that kind of make the head-up displays work. There's certain things the windshield's got to have to be able to go ensure those head-up displays work. And then you brought up AR, augmented reality HUD. So the HUD image is sitting on the windshield, but it doesn't look like it's sitting on the windshield. It looks like it's floating in front of the car. And if I can get it to float like way in front of the car, maybe as I'm driving the vehicle, I can, if I want to do, maps and things like that, like, hey, I got to get off at this exit, and you see now the arrow pointing that way, versus you having to kind of look down at the center screen. And so there's probably maybe a safer way when you're in control of driving the vehicle.
Yeah, Land Rover showed something years ago, but it was, you're driving through Paris and, it sees the Arc de Triomphe and it takes that and it identifies it in front of you and says, lights up what it is. And then if you want to, you could gesture control, swipe down, and then it throws the Wikipedia page for Arc de Triomphe onto the screen or reads it to you or whatever.
Oh, yeah, the
And
information.
then you crash.
Well, no, it's driving itself. But, you get like a self-guided tour
Right.
of wherever you are.
Yeah, I think there's some that you probably saw at CES. People are putting displays in the side windows of cars, so like as you're looking out the window, you can see all that information.
Okay.
BMW did a whole thing at CES showing off their latest. It's like a super HUD. It goes like across the screen. And
P-HUD, I think they
Yeah,
call
it
it, yeah.
shows off everything.
P? What's the P for?
I can't remember, like performed or progressive, I think.
Yeah.
But it goes all the way across the from left to right of the windshield.
A pillar to A pillar. But I guess the question I'm asking is, there's been a lot of promises. I'm still waiting for AR to be a thing. Like, I know a lot of the kids use it, and the headsets are getting smaller. I'm talking about personal electronics.
Yeah.
But from a HUD and AR in the car, the physical limitations seem to be, it just doesn't look very good. Like, even we're now 25 plus years with the HUD. Like,
Some are better than others.
but it's just not crisp enough. I think it's fundamentally, it's never going to be dark enough.
Foiled by sunglasses.
Well, you're driving
Yeah.
you're driving in daylight, and glass is coming through this thing, and you're trying to project something bright or brighter, as bright or brighter than the image, and it always looks kind of faint and not sharp.
What's in your lab? What haven't we seen?
Yeah, well, we're making them bigger, a lot more color, and kind of project them further down. That's the augmented reality piece of them. So that stuff we are working on. But I think it's a really tough problem for the car companies. They don't they can't just have only a HUD or only a center stack inside the vehicle. They got to have all these systems in there with a lot of redundancy. And some consumers like HUDs. Others turn them right off.
Yeah.
They're like, well, how do I solve for all of the use cases that are out there? So it's tough as they're playing around with all the different technologies.
Yeah.
And right now, contemporary Mercedes and Audis use augmented reality on the center screen, the navigation screen. And when I pay attention to it, it actually works really well. I just forget to pay attention to it because I'm looking through the windshield, not staring. But it's good. It says make sure you're in this lane. It'll show you a map on the image. But it'd be better if it could be projected.
Yeah.
And they're starting to do that too. Where the head up, they'll tell you the lane.
Here's my theory, because what's great about the automotive industry is that it's like a graveyard of really awesome but ultimately unsuccessful technology, right? Like all these parking systems that all the manufacturers put in the cars, nobody uses them.
No one's ever used
like
one
the
successfully.
push button, and I'm going to wait 30 seconds. I'm like, I
No.
can park this thing faster myself.
Yeah.
There's another one. I just slipped my mind. But I suspect that HUDs and true augmented reality are going to come in the age when cars are fully autonomous and there's no more windshield. Like we're literally sitting in front of like
Just in a theater.
like a pod, and it's just going to show. You want to see the road ahead? Great, hit the button. There's a camera view. Or you want to watch a movie? Boop, and then it just projects on the screen. And just like we're starting to lose the back windshield
Yeah.
in a lot of these cars.
Yeah,
Like the
the
Polestar.
Gone.
Ford.
Gone. Like,
Yeah.
what do you need it for? Like,
Yeah.
maybe we can just turn the seats around when the car's driving itself, and then there's your theater.
And there's a lot of interesting stuff happening in the back seats now.
Oh, yeah.
You go to a lot of folks get driven around in cars. You go out to China. There's
The-
a lot of folks in the
the
back.
40-inch flip down ultra high def in the 7 Series is like, and that's one where Ed was talking about on the lawn in 50 years at Pebble Beach, and I'm like, well, why'd you put a TV in there? The quality, and then I looked at it like, no, it'll never get better than this. It's really good quality.
Yeah. And display makers doing a good job of keep innovating. They're kind of making displays brighter and brighter and brighter so they can work in all different types of use cases.
Yeah. All right. Well,
Very good.
this was awesome.
Yeah.
Thank you so much for coming in and chatting with
appreciate
us. We will, I guess about the cars that
Yeah.
are coming
Yeah.
with the optical fiber, because mum's the word on your end.
Well, but it sounds
or-
like that's going to be, some big manufacturer will greenlight it first,
Yes.
and they'll have a lot of brands. And
Well, when we're ready to
Sure.
share, we'll definitely share with you and get back here.
And then we'll also, I learned from your colleague that we can't just look at the bottom corner of the windshield glass to see whether it's Corning, except for the case of like the Jeep.
The Jeep, they brand it.
They brand it.
'cause otherwise, it's the glazer. Is
Yeah,
the
the
branding?
tier one. Yep,
Yeah. So it's the supplier you supply with your technology.
correct.
But it's fascinating stuff. You're if you're an iPhone, actually,
You're
Gorilla-
probably on Galaxies
Gorilla
too, right?
Glass is also on non-iPhones. It's in.
Oh yeah. So
yeah.
the Apple's
Yes.
third of the market. We go after the other 2/3 as well.
So you're probably already a Corning Glass
Owner.
owner or
Probably in your pocket, on your
beneficiary, right, of the technology. You might be listening to us or watching us on a device through Corning Glass.
Odds are.
Glass, yeah.
Odds are.
Yeah,
definitely.
And fascinating stuff. And I'm looking forward to, again, for me, the holy grail is how do you get the weight out of these cars? If you want EVs to, you guys complain EVs don't sound good or they don't have the lightness of like my Miata. Well, it's going to take all of the manufacturers, all the suppliers to pull weight out.
Also,
Actually, a big shift in batteries is going to be the biggest help, but getting all the weight out.
The computing power, like you were talking about screen latency, if you have every control is now on a screen, it's got to be ultra quick. And so that's exciting for moving the data faster.
Yeah.
We're trying to do our part.
Yeah, well, I mean, that's the number of times I'm like, why is your transmission so slow? It's like, the CAN bus.
Yeah.
So,
All right. Mike Kunigonis, VP, General Manager of Corning Automotive Glass Solutions. Thank you so much for coming in.
Thank you.